Hello, friends. Welcome to all of you. Now, today's topic is finite automata, or you can also call it finite state machine. So, you can consider finite automata as a mathematical model to validate some languages or to validate some strings. You can say so. Basically, finite automatas are used to validate some strings like if some string is belonging to particular language, then by applying some logic we will design one mathematical model to accept all strings that belonging to that particular language. So for this you can consider this as a box, that is you can call it as finite automata. And what it does, it has one pointer. You can call this pointer as read head read head, right? And this read head, what it does, there is one storage, that is fixed size storage is there. You can call it buffer. So in that buffer some string is written like 0 1 0 1, like this. And this read head starts from leftmost position or leftmost character of this string, and then it reads the string from left to right. And once it is reading one character, it changes its state again and again. And at the end of a string, when it reaches the end of a string, if the machine is in one of the final state of the machine, then you can call this string is accepted, or you can call this string is the valid string of this particular language. And if this at the after reading complete string, if finite automata or finite state machine is in particular state which is not final state, then you can call or you can say this string does not belong to that language, or this is the invalid string for that particular language. So our main purpose is to create the logic of this finite automata. To create the logic of this finite automata. See, as we have already discussed, like finite automata of two types: without input, or you can say binary output. Without output or binary output. So it gives two type of outputs: yes and no. So if I want to know whether this string is belonging to some particular language, so after the finite automata will start reading this string from leftmost position, and after reading each character, it will change its state. It will change its state, and at the end of string, after completely reading this string, if the state of machine is one of the final state of the machine, then you can this will gives us output yes. That means this string belongs to that particular language. Now suppose the language, it doesn't belong to that language, then after reading complete string, the machine will be in such an state which is not final state. So that will gives us output no. That means this string does not belong to that particular language. So this is the block diagram of your finite automata. I hope this would be very much clear. And one more thing, as I told you, that after reading each character, that particular machine or finite automata changes its state. That may, and there are finite number of states only. There are finite number of states only, and that's for this reason only we also call this machine as finite state machine, which is having finite number of states, or we can call it finite automata. So our purpose is to make the logic of this particular machine for different languages, right? So I hope this would be very much clear to all of you. So finite state machine can be represented in two different ways. One is set form and other is graph form. One set form where we represent different types of set, So first will discuss set form, and then we will discuss graph form. In set form, different types of sets are created for representing a particular finite state machine, like set of all possible state, all possible states of machine. Then one more set will be there, set of input symbols. One more set we will create there, set of final state. One more, two more information we will give, set of transition rules. As we have discussed, friends, like machine, after reading one character from the string, machine changes its string from one state to another state. That means it is taking transition from one state to another. So there must be some rules to define these transitions. So one set we will be having set of transition rules, and one more information is there, initial state of the machine. So what is the initial state? Initial state is such an state, friends, where machine will stay without reading any input symbol. So these kind of different sets we define to represent finite state machine. So this is the set form of the machine. So friends, this is another form of representing finite state machine. So first was set form. In that particular form, we have defined four different sets and one initial state we have defined. Now in graphical form, we can represent a finite state machine. Now in graphical form, we create a structure like a graph. As you know, friends, graph is a collection of node and edges. So in this particular machine also, we will create some node and edges, right? So how we can use this particular node and edges? So to represent, see, there are different types of states of the machine. One is initial state, then some are intermediate state, and some are final state. So to represent different types of state, different symbols we use. So see, you can see here, if we are using simple circle, then it is representing state, or you can say intermediate state. So to represent intermediate state, we use just circle. Now to represent transition, as I told you, friends, machine reads one input symbol and changes its state from one state to another. That means it is doing some kind of transition. And for transition, we need to define rules. So that rule we can define with the help of these edges. So both edges are directed edges, and input symbol is mentioned over each edge. So transition. This is transition, and you can say it transition rule. Now, initial state, to represent initial state, we use circle as we use in intermediate state. So along with the circle, we use one arrow pointing inside the circle. So this is how you can represent initial state of the machine. And then one more kind of state is there, final state. To represent final state there, we use double circle. So like this, you can represent any final state of the machine. any final state of the machine. So this is how these different symbols are used to represent different things of the machine. Now I have also created one example machine here to explain it in better way. See friends, this machine, suppose I tell you to create a machine that accept only single zero, only single zero. That means it is only accepting single zero. So it will be some initial state. So I have mentioned one initial state here, and like this. So see, for initial state, how we represent initial state? Circle, and then an arrow is there pointing inside the circle. Now to represent the name of state, we can write any symbol inside the circle. So here I have written q0. That means q0 is the initial state of this machine. Now if initial state is there and after accepting 0, it will be in final state. So I have created one more state there with name q1 and I have made it final state. So as it is accepting only single zero, so it will be in initial state, then it will read some input symbol 0 and then it will enter into the final state. That means here we have mentioned one transition from Q0 to Q1 on reading input symbol 0 via this is. Now you can see here this is a directed is and I have mentioned one symbol 0 here over the is. So you can see how this machine is doing this. So machine is an initial state which is Q0, then it reads 0 and it changes its state to Q0 to Q1. And as Q1 is the final state, so that means 0 is accepted by this machine. 0 is accepted by this machine. So this is the simplest example of the finite state machine in a graphical form that I have explained here. I hope this would be very much clear to all of you. And if you have any doubt, you can write or you can comment for this video, and I will definitely reply your all comments. Thank you so much.